Hello and welcome back to the Aimless Electron. If you're just tuning in, this is the third part in a multi-part series on a DIY reflow oven. In this episode, I'm going to take a look at some of the individual pieces that are going to go into the final circuit. I think the first thing I'm going to start off with is the USB stack and that AT command processor. That way, for the rest of whatever I test, if I leave that intact, I can have a little bit of debug or interface from my computer to the device itself. So let's go check that out on my desk. So I'm going to breadboard this thing starting with the XMega on this little breakout board because, well, this little breakout board doesn't have any of the components on it, so everything that we need to use is going to be on this breadboard. I think it makes it a little bit easier to transfer that to an actual circuit board later on. And I'm also going to use this crusty old breadboard from Radio Shack. It's, seen some of my trials and errors with exploding components, so try to ignore some of that if you don't mind. I'm also going to use this little mini USB-B adapter board that I got from Adafruit. It's a little 5-pin header, but it makes it really easy just to plug right into our breadboard here. I'm also going to use this 317T voltage regulator, which is an adjustable voltage regulator for my 3.3 volts. I just basically pulled this off another board that I'd worked on before. So stick around and we'll wire that up and all the power that's necessary in this little USB connection to the board. And there we have it, 3.34 volts, so that should work. And just real quick, this is just coming off a power brick that I put some banana connectors on. Makes things really nice. If I remember correctly, we're using a 510 ohm resistor here because it's a fairly common value. And then I have this 820 ohm resistor here because again it's a fairly common value, and that's what's creating the voltage split for me. And this is just a lower voltage, I think, 510. Oh no, I think that's 470 ohm, just to show that we've got power. Now on to the rest of the wiring. So that should be all of our power connections. Now let's do the in-system programming. For that, we just need to hook up these 4 connections here. We have power sense, which is just this thing's way of reading what the power is, and then it reports it off to Atmel Studio. We have the ground, of course. You need a ground. And then you have this, which is connected to the reset pin usually, which in this case should be pin 35. And this is usually connected to the PDI port, the programming device port, which is right next to it on pin 34. So that really should be it. And if I power this up, we should be able to see on the computer, or at least in Atmel Studio, that we can talk to this chip. So we'll go take a look at that in a second. I'm just going to throw the jumpers on here for the USB real quick. All right, I moved things around here a little bit because, well, you want these to be the same length as far as the D- and D+ for USB because they're differential pairs, and it means that it takes the difference between the 2 signals to determine if it's a 0 or a 1 on the bus, and they have to have a signal arrive at the same time. So I just flipped it around. That way they're also in the same order. Made things a little bit easier, and just moved these over as well. I went and confirmed it on the computer that pin 26 is D minus and pin 27 is D plus, so that looks like it matches up according to the little silk screen on this. Let's plug it in, make sure it doesn't blow up, and we'll see if we can talk to it on the computer. But the first thing we have to do is plug this guy in. Green light, that's good. Hopefully that red will turn to green when we got power on it. We still have the light here. This thing isn't heating up, there's no smoke coming out of anything, and it's not hot. Let's see what happens. Before I go any further, there were a couple mistakes that I made that I realized before I got too deep into the code, thank God, and I'll point them out real quick. This right here, this yellow wire, actually accidentally called it the reset wire, but it's not. It's the PDI wire, and the green one's the reset, so I had to swap those. Next, I checked out some hardware schematics, and I realized that I forgot these two resistors. They're important for impedance matching, and they're just little 22 ohm resistors. I also moved this board because of whatever I had blown up here kind of melted things, and it wasn't making a great connection. But besides that, we're good to go. And then I just plugged this in, and we'll see if it works. Alright, I have Atmel Studio here open, and right now we're running version 7.0.1188, and I think that's the latest that's out right now. The XMega is plugged in, so we should just be able to go to Tools, Device Programming. I've already got this selected and the XMega 128A4U selected. Our interface is PDI. Apply that, and if we read it, we should be able to get, there's our device signature and our voltage according to the programmer. So it looks like we've got this thing hooked up correctly. Now we can move on to playing with the code. With Atmel Studio 7 already open, we'll go ahead and add the new project. We'll call it, that's fine. We'll call it the DIY Reflow Oven V1. And make sure you have GCC executable selected. Click OK. We'll now select the processor. In this case, or the microcontroller. In this case, we're using an XMega A4U, or 128A4U to be precise. Let it build the project, and then you can go up to ASF, select the ASF wizard, it'll pop up this message saying that you don't have a board, and you really don't, so you're going to click OK on this and choose a user board template, which is just a default blank one. Click Next, and let it import all that stuff. Click Apply. We're going to be using the USB stack with the CDC drivers, and that's right here. There's or not CDC drivers, but CDC setup. There's a whole bunch you can use. You can do just about anything with it, but CDC is what we want because we want to emulate an RS-232 port. So we'll add that into our project and apply it. And click OK, and that'll add what we need as far as the code. There's not a ton left to do here. There's a couple pieces of code that we have to add in, and I've actually gone and read over as much as I could, including some of the ASF source documentation and examples on how to do this. So I'm just going to pop some of that code in right now and make some of the changes and try to explain it along the way. The first thing you'll notice is that we have two main.c programs now, and we only need one. So I'm really going to just copy a bunch of this over what we currently have, just so I can, well, you know, make the one we have look nice and get that other include in there. I'm going to leave this while in place because that will represent our main program loop, but really up until that point we aren't going to use it. We're just going to let it get stuck right there, which is fine because everything else is going to be based off of interrupts for now. Here are the couple pieces that need to get pasted in here, and these are all located in the header files and all referenced, so I don't have to make any changes there. We do need to take a look at a couple of these configs though, mainly being USB and clock. Board, it doesn't have anything in it, and sleep manager, we're not going to use the sleep manager, so we won't even worry about it. For a clock config, we want to make sure that we're actually using the 32 megahertz RC unless we decide to go with an external clock eventually, which we may have to depending on if we can use it or not. We also have to enable this this PPL, this phase lock loop divider, and I'll just uncomment that. Finally, we need to make sure that we're configuring our RC, or calibrating our RC clock source for 48 megahertz instead of 32. And that should do it as far as that goes. Now let's go over to the USB config. There's a couple things we can change in here. We're not going to be using any board power, so we can leave that at 0. And I'd rather just have this on the same line, so I'll put that over there and comment that out. There's a couple other things we can change here if we want to have our custom names. We'll leave the USB serial name as it is. Manufacturer name doesn't seem to get picked up, but I'll change it to the Atmel Electron anyways. And our product name is going to be DIY Reflow Oven V1. 1. We're not at 2 yet, I know. We're going to be looking for a couple of these events to happen, or these callbacks to happen. I call them events because I'm used to programming in C#. But yes, they are just callbacks. We're going to use 4 of them: the CDC enable, CDC disable, the receive notification, and the transmit empty notification. A little bit further down is the setup for the COM port itself. These are all fine and they're pretty standard, and I don't think there's anything else really that we have to do here. What we do need is those callback functions, so we'll go ahead and set those up. 2 of them, the CDC callbacks, are available already from the example software that's provided, and the other 2 I have to create myself. Oh, and so it doesn't get confusing, I'm going to delete this old main, and we'll use this one. And that really should be about it. We're not going to mess with anything else yet. We're just going to see if we can get this to work. And well, we'll select our tool right away. That would help. That's still plugged in. Cool. A4U, PDI, apply. That's a good sign. Read it. And we're good. Okay. Well, let's see. I believe there's one more call we need to make here, if I remember correctly. Yeah. Here we go. We need to call USB start, our final piece of code here. Or UCD start, sorry. And that should do it. Let's see what happens when we program the device. By the way, that should build, compile, and upload automatically if everything works. Oh, I forgot to select the tool here. And I think that was it. Went that fast? Now let's see in our device manager if we've got any COM ports. Here we go. It's there. It worked. Really, it was just about the first try. If you go over to reported device descriptions, you'll see it says DIY Reflow Oven V1, just as we typed in. So as a little test, I added this line of code to the receive notify interrupt handler. And basically all it does is gets a character from the serial and echoes it right back out, puts it right back out. So let's run this and make sure that it uploads. Built and uploaded very quickly. I'm going to start up TerraTerm and we'll connect it over to COM3 right away. And then I will set up the serial port to be at 115200. And if I get text back, it works. Sweet. Alright, we did it. We set up the hardware and then we set up the software to communicate over USB as a serial device, and it worked just perfectly. On the next episode, I'll get more into the software, not so much in the hardware probably, but I will also try to lay things out ahead of time so you're not having to go through the agony of watching me type it in. If you liked the episode, give it a thumbs up, subscribe, and leave me some comments. But in any case, I'll see you in the next one.